Hi everyone, this is your math guru. Today we're going to learn how to solve rational inequalities. If you like this video, please click on the like and subscribe button below for more easy to understand math concepts. To solve rational inequalities, we have to write in the form the function of p over function of q less than 0. The less than could be greater than, it could be greater or equals to, or less than or equal to. After writing in that form, then we solve for p of x equals to 0 and q of x equals to 0. After which, we put our solutions on a number line in order to test our point. Let's look at the following examples. In the first example, we have x minus 3 over x plus 2 greater or equals to 0. This is already in the format p of x over q of x greater or equals to 0. So we move to the next step, which states that we are going to equate the function px to 0. And for this question, we have x minus 3 as a function equals to 0. Therefore, x equals to 3. Then we equate our q of x to 0. Our q of x here is our x plus 2 equals to 0. Therefore, our x equals to minus 2. So we have two solutions to work with. We have x equals to 3 and x equals to minus 2. We are going to test this point on a number line. If we have a number line, we have this is to negative infinity, this is to positive infinity. We have a point, or the solutions we got, that's x equals to minus 2 and x equals to 3. Because the inequality says greater or equals to 0, we are looking for points on the number line that are greater or equals to 0. We have three regions to test. We have the first region, we have the second region, and the third region. Before we start testing a region, let's test our solutions first. The first one, we have x equals to 3. If we slot in x equals to 3 in our equation, we are going to have at the top, if x equals to 3, we have 3 minus 3 at the top, and at the bottom we have 3 plus 2. This will give us, it must be greater or equals to 0, and if we test that, that's 0 over 5 greater or equals to 0. That will give us 0 greater or equals to 0. And because it's 0, that is a positive solution, so we are going to shade it. A circle is going to be shaded. Let's test the next point. We have x equals minus 2, and if we slot that back into the equation, we have, or the inequality, we have at the top minus 2 minus 3 over minus 2 plus 2 greater than or equals to 0. But we know that this is minus 5 over 0 greater or equals to 0. We know that if we put minus 5 divided by 0 in our calculator, this is undefined. So therefore, x cannot be equals to minus 2. So we are going to have an open circle on our point minus 2. Now we need to find the signs of each region. Remember, the inequality says greater or equals to 0. So we are looking for positions that are 0 or greater than 0. And being greater than 0, we are looking for positive positions. Let's try in the first region. In this region, let's pick a point x equals 3 minus 3. If x equals minus 3 and we slot it back into the equation, we are going to have minus 3 minus 3, that's minus 6, over at the bottom, minus 3 plus 2, that's minus 1. And if we divide minus 6 by minus 1, we're going to have a value greater or equals to 0. We're going to have a positive value here. So therefore, for this region, our value is going to be positive. So let me put this as positive. I'm going to use my red symbol. Now let's test the next region, which is this region. In this region, let's pick a value x equals to minus 1. If x equals to minus 1, if we slot it back into the inequality, we have at the top minus 1 minus 3, that's minus 4, over at the bottom, minus 1 plus 2, that will give us positive 1. The value here, minus 4 divided by 1, is a negative value, which is not equal to or greater than 0. So if you have a negative value here, I'm going to put my negative value here. And then let's test the last region, x greater than 3. We can pick any value. Let's say x equals to 4. If our x equals to 4, and we slot that back into our inequality, we have at the top 4 minus 3, that's 1, over 4 plus 2, 6. 1 divided by 6 will give us a positive value. So therefore, in this region, we are going to have a positive answer. And based on our inequality sign, we need regions that are positive. So we are going to have x minus infinity to minus 2, union of, we have 3 to infinity. And if we want to put it in our inequality sign, using our inequality, we have x less than minus 2 or x greater or equals to 3. We use or equals to here because of our closed circle, and we leave it at less than minus 2 here because of our open circle. In this second example, we have 3x minus 4 over x minus 2 less than 5 over x minus 2. The first step, we need to write it in the form p of x over q of x less than 0. So writing it in that form, we need to move our 5 over x minus 2 to our left-hand side. That will give us 3x minus 4 over x minus 2 minus 5 over x minus 2 less than 0. Already, the denominators are the same, so we can match the numerators. We're going to put it under the same denominator, x minus 2. At the top, we have 3x minus 4 minus 5 less than 0. And if we write that or collect like terms, we are going to have 3x minus 9 over x minus 2 less than 0. That is looking at like a standard form. So we are going to be working with this inequality. The second step says equate a p of x to 0 and q of x to 0 to get our solutions. So p of x here is our 3x minus 9 equals to 0. We have 3x equals to 9. Therefore, x equals to 3. That's one solution. The second solution, q of x, we have x minus 2 equals to 0. Therefore, our x equals to 2. That's the second solution. Now, we need to go to our number line to test our points. We start from negative infinity to positive infinity, and the points or the solutions we have are 2 and 3. Let's test each of those points. If x equals to 2 and we slot that back into our function or our inequality, we're going to have, if x is 2, at the top we are looking for a value that is less than 0 or negative. So if we put that in, we have 2 times 3, that's 6, 6 minus 9. 6 minus 9 at the top. At the bottom, we have 2 minus 2. That will give us minus 3 over 0, which is undefined. So therefore, x cannot be equal to 2. So we are going to be having an open circle on our 2 because x cannot be equal to 2. Let's test our point x equals to 3. If we put that back into the inequality, we have 3 times 3, 9. At the top, we have 9 minus 9 over x minus 2. That's 3 minus 2. 3 minus 2, that would be 0 divided by 1. If we test, that would be 0. But our inequality says, the sign says less than 0, not less or equals to. So we are going to be having an open circle on our 3. Now we need to test our 3 regions. We have our first, second, and third region to test. For each region, because our inequality says less than 0, we are looking for negative values. So for the first one, we are going to test for this region, let's say our x equals to 0. If our x equals to 0 and we put that back into the inequality, we're going to have 0 times 3, 0, 0 minus 9, divided by 0 minus 2, that's minus 2. And that will give us a positive value, 9 over 2. And because it's giving us a positive value, that means our x cannot be 0. We're going to be having a positive value here. I'm going to write positive here. Then I'm going to test a region between 2 and 3. Let's look at 2.5. If our x is 2.5, x equals 2,5. Slotting that back into the inequality, we have 2,5 times 3, that's 7,5, minus 9 over 2.5 minus 2, that's 0,5. I'm going to be having a negative number. That is, my value is going to be less than 0. That's minus 2,5 minus 1,5 over 0,5. That will give me a negative value. So therefore, for this region, I'm going to have a negative number. I'm testing my last region. If I have, for example, x is equal to 4. If I slot that back into my equation, I'm going to have 4 times 3, 12 minus 9 over 4 minus 2. That will give me 3 over 2, which is a positive value. So therefore, for this region, I'm going to be having a positive value. So therefore, because our inequality says less than 0, we are looking for a region that will give us a negative value, and that is this region. So therefore, writing it, we're going to have the solution to this inequality is going to be between 2 and 3, or writing it in the inequality boundary, we're going to have 2 is less than x, however x should be less than 3. Let's look at one more example. In this example, we have x minus 4, x plus 1, all divided by x minus 3 less than 0. We already have it in the standard form, which says p of x over q of x is less than 0. So now we need to equate each bracket to 0. That means we need to equate the p of x, and in this question, our p of x is x minus 4, x plus 1 equals to 0. To get our first solution, we are going to have two values. It's either we have x equals to 4 or x equals to minus 1. For our denominator, we have x minus 3 equals to 0, so therefore our x equals to 3. You can pause the video and use your number line to find the positive and negative regions for this question. Our solutions is going to be x equals to 4. We need to try that out. We try x equals to minus 1 and x equals to 3. If we try out each of these values, we're going to have open circles for all the solutions. In the other regions, we need values less than 0, that is negative. And if you try it out, pick any spot less than minus 1, you're going to have a negative value here. Between minus 1 and 3, you're going to have a positive value. Between 3 and 4, you're going to have a negative value. And anything above 4, you're going to have a positive value. So therefore, our inequality is going to be x is less than minus 1, or 3 is less than x, and x is less than 4. Thanks for watching. Bye.